Hi, this is Mr. Urrego, and we're going to divide right now. We're going to divide two rational functions. Okay, so the whole thing with this is that if you notice, I have trinomial, a bunch of trinomials, and all of them, not all of them, but almost all of them have a leading coefficient. So that means you have to factor. This one is an easy one, but these three are more complicated. Okay, so let's approach it. The first thing you want to do when you're dividing rational expressions is you have two fractions. When you're dividing, you want to flip the second fraction, okay, and turn the division into multiplication. So let's do that as to start. So I'm going to keep the same one. The first one is going to be 2x squared minus 3x minus 2 over 2x squared plus 11x plus 5, and now I flip this too. The 4x squared is going to go on the top, and the x squared minus 5x plus 6 goes on the bottom. Instead of division, now it's going to be multiplication. Okay, and this will make it a lot easier, everything. So now the whole idea from now is I need to factor, and factor. Okay, so I already factor all of those. Now we came from here to all these factors. So either you're watching a video that I inserted all the videos for the factor on each problem, or you're watching the video that I have straightforward, and basically you can go reference each one of them. There's a different video for every single problem. Okay, now the whole idea is that if I don't want to do it here because it's going to take me a long time. So dividing fractions, rational expressions, flip the second fraction. I got to factor each one of them, and I did factor each one of them. Okay, now what happens is you have two fractions, the same as two regular fractions with numbers. When you multiply this, then you know that you're multiplying the top with the top and the bottom with the bottom. So instead of having the product right there, I just can extend the line. Why? Because if there's no signs between the parentheses, you know that you're multiplying. Okay, so now I'm multiplying all of them. From here, I need to reduce. Okay, so let's start reducing. One from the top, one from the bottom. Now, better idea right now. Before we start canceling out, let's find the domain of the function. Okay, because most likely they will ask you for the domain of the function. All right, so remember, the domain are all the values that make your denominator 0. So here, all right, domain of restrictions, x plus 5. If the x is negative 5, then that will make this 0. So x cannot be equal to negative 5. From here, 2x plus 1 equals 0. 2x plus 1 equals 0. Minus 1, 2x equals negative 1 divided by 2, x negative 1/2. So I don't want x to be negative 1/2. These are the restrictions in your domain. Minus 3, change the sign. X equals 3. I don't want that value. So because if the x equals 3, 3 minus 3 is 0. I don't want zeros in the denominator. Here, x cannot be equal to 2. Basically, you just change the sign of each number. Change the sign, and those are the restrictions. So if they're asking for the domain of the function, then you'll put all real, except when the x equals 5, negative 1/2, 3, or 2. And that will be your domain of the function, okay? Remember, you find the domain before you start canceling out, before you start reducing. All right, let's go back to the problem. We have all this. Let's start reducing, canceling. Let me see, do we have an x minus 2? Yes, we do. X minus 2, x minus 2. 2x plus 1. Oh, we do have 2x plus 1 canceled out. X plus 5. X plus 5. X plus 5. I'm doing different signs so you know what we cancel is. Oh, look at this. Minus 3. Minus 3. Minus 3. Wow. Everything cancels. What's left? Oh, the 4 is the only thing that didn't cancel. So imagine you do all this process and your final answer is 4, because that's the only thing that didn't cancel. 4 over 1 is 4. So your answer is 4. If they ask for the domain, it will be all real. X has to be different than -5, different of -2, 1/2, -3, and -2. I'm sorry, different of 3 and different of 2. Okay, and that'll be your answer. Long process, practice a lot of things. Okay, so that's how you divide rational expressions. Thank you for watching. I'll be learning from these videos. If you do, please make sure you subscribe to our channel and hit the notifications bell so you get notified as soon as we upload videos. Visit our webpage, like us on Facebook, and most importantly, share this video, please. Put it on Instagram, Facebook, Snapchat, share with your friends, your family. Help us reach a lot of people so we can get a lot of subscribers and a lot of views. That's going to support our channel. That's the idea. We help you, you help us. All right? Thanks a lot for watching, and I'll see you next time.